Hi, in part 15 we are going to see these options: repeat, replace, how to create the flexible component, how to check the interference between the assembled components, and the interface assembly. These things we will see one by one in Creo. To explain these things, I am going to create one window frame. See, for example, one window frame. This 600 and this size is 900. For this size, we will create one window frame using the standard sections, standard tubular sections. See, this is the rectangular hollow section. Square section or rectangular sections we can use. Now we are using a rectangular hollow section. See, these are all the sizes: height and B, H and B. I am going to create one cross section in Creo. New. I am creating 50 by 25, 50 by 25 by 2. This I am creating 50 by 25 by 2. This one is 50 by 25 and the thickness is 2 mm. This we will maintain 1 feet both side. Just this is a round piece and the round. Outer radius is 4, inner radius is 2 for 2 mm thick. Inner is 2. By pressing the control, select the rounds, edges. The inner is 2 mm. For outer I am creating one more set. Outer is 4 mm. Okay, outer is 4 mm. Inner 2 mm. Only 3 edges are there in the inner. I think we missed one. 1, 2, 3, 4 is there. Okay. Now we have created a section. Either we can use 50 by 25 or 60 by 40. I am going to create one instance with the size 60 by 40. Okay, we will create a later. First we will create the frame, file, new, the assembly. I am creating frame. You select the unit, give OK. I am selecting the first section. We can use default for the first component. See, we are given the height is 900, so we have to make this standard sections height into 900. So I am making this into flexible component. To achieve that, make flexible. Here also we can do make flexible, or by picking on that we can do make flexible. See, select, pick the geometry. Here we are getting the height is the 300. Select the dimension, give OK. Here we are getting, give the value. The value is 900. Give OK. Here we have a lot of options. First I am one by one we will see. This 900, give OK. Now the frame become 900. I am going to add one more frame. See, component add. I'm selecting the same component, placement, distance. It should be from this surface to this surface 600 and coincident, the front coincident with the front one. Similarly the bottom side coincident, bottom coincident with the bottom. Do OK. Oh, the dimensions come, check. Okay, I am changing the distance, this into outer to outer, so I am giving minus 600 to move to that side. Okay, now we have to make this section's height equivalent to this one, so I am picking this, right pick, make flexible, pick the component, select the dimension, give plus. Here instead of by value we can select the curve length, go to hidden. We have selected the curve length, select any one edge of this one. Okay, now based on the curve length this height will vary. Okay, give OK, shading. Now we are going to create crossbar. Component assemble, the same we are using. We have to place like this, placement, coincident, this one coincident with this one, the front one coincident with this front, the top one coincident with the top of this one. Give flip. Okay, okay, now properly placed. The length should be between these. Okay, make flexible, click on that, select the length dimension, 2 plus. Here instead of selecting by value or curve, select the distance, go to hidden, distance from this surface to this surface, go OK. Okay, now why we are giving like this means if we are changing this, automatically it extends and attached with this end. Then the bottom one, I am using the same component, I am assembling similar way. This surface must coincident with this one, and this one with this one, and the bottom one with the bottom one. Placement, first one is coincident, third one is also coincident, flip, go OK. Now right pick. Here also we can do edit definition, and the first we have to make the flexibility by right picking and make flexible, then only we can edit here. Pick one, select the value, give here curve length of this component. Okay, now we have created a frame. Okay, we have created one frame. Then on that we are going to place a glass or metal plate. Metal plate we will keep one metal plate on that. For this is the size, 900 by 600. Okay, this frame we have created. I am creating one sheet, solid or sheet metal, anything. planar one, references define, sketch view. Size is 600 by 900. Here I am creating datum points. Okay, 1 mm. Okay, 1 mm thick. Now we will assemble both. Fine, I am creating one more assembly. Final assembly. First we have to assemble the frame. As this is the first one, we can go ahead with the default. On that we have to place the plate. The surface should match with this one. Bottom should match with the bottom one. Side one match with the side one. Okay, now we assembled this one. For better visibility we can make transparency. I am giving yellow and making this is transparency. Not more. Let it. Okay. We have created frame and a plate over that. Now we will check the interference. First we have seen the flexibility. This one we have seen. Now you know how to create this flexible. Now the global interference check. Analysis, global interference. Preview. We don't have any interference. If we have any interference, we can identify here. Just I am creating one interference. See, here I am creating one interference. Flexibility, varied items. Here instead of 500, I am going to give 510 or 520. Change by value. 520 I am giving. Okay. Now we have created the interference here. See, by visual we can check. Now we will check the interference. Analysis, global interference. See, now we have interference here. If we check in this assembly also, we will find the same interference. Analysis, global interference. See, we have interference between these two components, 50-25 by 2, 50-25 by 2. Okay, in this way we have to check the interference. Now we know this. Okay, now I am removing the interference. Now we have seen this one. Now we are going to join this plate and the frame with bolt and nuts. For that I am going to create 4 holes approximately. For that I am making mark. Atom sketch, sketching plane, sketch view. Here I am creating 3 points. Here 1 point, here 1 point, here 1 point. I am creating center line and making symmetry. And all the lines are in the vertical. then the dimension 25. Okay, now we have created 3 holes, 3 points. On that I am going to create cut. Settings, 3 filters, features. See, now we can see the point. I am going to create one cut on or hole. I am going to create one hole using cut option. Extrude, placement, define, sketching plane, sketch, sketch view. Select the go to done. I am going to select this as a reference. I am creating one hole for M10. I am creating hole 11 through all. I am creating one hole through all. Okay, regenerate. Okay, now we have created one hole. In creating cuts and creating component in the assembly itself is called top-up approach. Now we have created the cut in the assembly itself. See, edit definition. We know these options. Here one more option is there, intersect. Pick this one. See, automatic update. In the automatic update, if you open this one, if you open the frame, whether you can see the holes or not. Setting, 3 filters, features. Okay, now we don't have holes here. We don't have holes here. If we need holes here also, we can control this one. See, go to extrude, edit definition. In the intersect, here only in the top level this hole is shown. If you want to show the hole in the frame also, we have to remove this one and give the part level. Okay, give okay. Now if you open the frame, see, we have the holes. Similarly, if we open the component, we have the holes. Okay, in the part the hole created, so it's reflected in this side also. So we assembled the same part opposite side. So the if we show the holes in this part, it also reflected here. So I am changing this one only in the assembly level. Intersect, we need to show the holes only in top level. Sorry, here top level. Okay, then we have to pattern. I am creating the pattern. Here point pattern, this point. In this hole I am going to insert one bolt, M10 bolt. I am selecting from library. Hexagonal bolt, M10, 50 length approximately I am taking. This surface coincident with this one, this one coincident with this one. Okay, now we assembled one bolt. Now if we want to repeat the bolt in several places, means we can use repeat option. Just pick on that, right pick, repeat. Which one is varying one? We should not select the common one. This one is going to vary, this constraint is going to vary, and this one is a flat surface. This is common to all bolts, so we should not select this one, only we have to select this one and pick add. After picking the add, select all the cylindrical surfaces. No need to do anything, continuously pick and give confirm here. That's all. This is a repeat option. Okay. Now we know this one. Repeat we know. Next one is the replace. for example, I am selecting this frame. Here 50 by 25 by 2 we have chosen. Suddenly the design updated for higher size or smaller one. I am creating one instance here. Tools, family table. 50 instead of 50 by 20, 60 by 40 we can take. 60 by 40 into 2. 60 by 40 by 2. Adding the dimension. So this one and this one is varying one. We have to add 60 by 40. Okay. Now we have generated one instance 60 by 40. The radius thickness is same. See? If the thickness is same, the inner and outer radiuses are same. For 2 mm thick, outer radius is 4, inner radius is 2. For example, 50 by 2. If the thickness is 2, the same inner and outer radius. Okay. So I am not included the radius in the family table. Only the width and 2 dimensions we have added. Now I am going to frame now. Frame. In the frame, I am going to replace this one. Now the design gets updated. Instead of 50 by 25, manufacturer asked to use 60 by what? Higher size. Replace. Here by default family table select one. Instead of 50 by 25, we have to select 60 by 40. Give OK. Give OK. That's all. See, now size increased. This is a replace option. If you want to replace this side, right click. Okay, I am replacing only this one. Replace. File open. Simply select and give OK. OK. Now we have updated for higher size. We have to check any interferences are there or not. Analysis. Global interference. We don't have any interference because we have given the relation as a length, curve length, distance from this surface to this surface. So there is no interference. Okay. View, window, final assembly. This side. Control G regenerate. Okay. If you want to replace the bolt, instead of M10, if we need M8, go to replace, select one. Here M8 is there. Same 40 or 45, give OK. OK. M10 replaced by M8. In this way, this is the replace option. Now we are very familiar with the replace. Last one is the interference, interface assembly. Interface assembly means we have to define the constraint, predefined the constraint. If you want to see, for example, if I want to in the corner, we have to add 4 gusset blocks. Means how we are adding. See, I am creating one. I am creating one block. Two inch by 2 inch we will take. 50 by 50. With 20 mm thick. I am going to see, pick the component interface. First, this surface is going to butt. The second, we are going to use this as a reference. The third, we are going to use this as a reference. This is predefined. In the component, we defined the constraint. Now save. Now we have to use the gusset here. Model, component assembly, gusset GU. I'm using the gusset. See, it asks where to keep this one. This one should be this side. Okay, then second one is this one. It should be with this one. This should be in the bottom. You can keep. Okay. Okay, now we placed the component having the constraint, predefined constraint. We have to choose the corresponding matting or aligning surfaces on assembly. That's all. This is called interface assembly. Okay, if we choose, whenever we are choosing this component, see, component assembly, asset, it automatically takes all the constraint. This is predefined one. If you want to place manually, means we have to pick this one. If we pick this, we can get the predefined constraint. Okay, this is called interface. Okay, now we have seen all the things. Interface. Okay, thank you.